So good morning, everybody. My name is Julien. I live outside Paris. It's my first time in Croatia. I don't know what took me so long, but thank you very much for inviting me. It's a very short stay, but I will be back. And I work for Hugging Face, which you may have heard about. And in the next 30 minutes or so, I'm going to try and convince you that you need to pay attention to transformers, in case you were not. And I will run some code, hopefully, to prove my point. So we've seen this trend coming up for a couple of years. I guess it was on a lot of people's radar. But now, I guess today, we have confirmation from the machine learning community and from the industry that transformers are eating deep learning. We've all been doing deep learning for a few years using traditional architectures like CNNs, RNNs, LSTMs, and I guess a million variations. And these were great, but as of a few years ago, transformers have popped up. And there's not a week that goes by without a new transformer showing up and breaking benchmarks and setting new state-of-the-art for computer vision and NLP and a whole bunch of different things. So thank you, CNNs and LSTMs. It was nice knowing you, and I guess there's still some value in what you are. But looks like transformers are the new thing. And actually, last year in the State of AI report, this was already called out very explicitly, also in the Kaggle data science survey. And the new State of the AI report came out just a few days ago. I really encourage you to read it. And very funny, it's slide 42. So it looks like the answer to the question on the meaning of life is transformers, because transformers are growing out of NLP. As you can see, the growth in computer vision is very spectacular, for transformer workloads. But it's also speech, and there's this category called other, which is very interesting, and that ties into the previous talk, which I really enjoyed. Thank you. And we see our own customers working with transformers on protein and chemical use cases and recommendation, and just more stuff than sentiment analysis and image classification. Multimodality is also rising pretty fast. I'm sure you've been playing with the text-to-image models that are completely insane, from DALL-E Mini to Stable Diffusion. I won't go into that today, but they're very, very interesting. And in a way, we see this deep learning 2.0 thing really happening, and maybe it's 1.1, I don't know. We'll know in a few months. So we're moving from traditional models to transformers. Transformers are really generalizing to a lot of use cases. We're moving away from building and labeling and cleaning huge data sets from scratch to using off-the-shelf models and transfer learning, saving a ton of time by not having to build those data sets, and just speeding up the time that it takes to go from business ID to POC to production. This is huge because you data scientists in the room, you are spending anywhere from 50 to 80% of your time writing SQL queries and Spark code and cleaning stuff, and just trying to get the password to that SQL database, right? So we're trying to save you from that a little bit. Machine learning hardware is a very strong trend. Of course, GPUs are around, but GPUs were built for graphics and 3D games. There's nothing wrong with that, and I know there are some ML-specific features popping up now, but we see a new generation of chips, from GraphCore to Habana Labs to Intel to a few others, which Hugging Face partnered with to accelerate training and inference. And I'll talk about hardware acceleration a little bit at the end. I'll show you some pointers if you're really interested. This is worthy of a full session. And finally, we're slowly moving away from expert tools. You and folks in the room have been working with the first versions of Torch, Theano, TensorFlow, and everything else a few years ago. You know what I'm talking about. If you're experts, you know what you're doing, and that's fine, and that's great, and we need the experts. But for everybody else, for Joe developer and Jane developer who just want to use a good model to make their app smarter, that was not an option. So I guess the mission of Hugging Face is to focus on developers and build tools that are simple enough with simple code and very little code so that you can use state-of-the-art models in your apps and not models from 5 years ago or more, right? We just want everybody to be on the same level here. So Hugging Face is a company. We're stewarding open source projects like the Transformers library, which you've probably heard about. If not, go and check it out on GitHub. It's actually one of the fastest growing open source projects ever. You see GitHub stars on this slide. I guess we're the rocket on the left, the blue line. So we have about 72K stars. We need more. We need to get 100K, so please start a project. And we're just growing faster than amazing projects like PyTorch or Keras or Spark. We're even growing faster than Kubernetes, which I find mind-boggling, given the fact that everybody seems to be in love with Kubernetes. So we see a lot of adoption in the machine learning community, in the open source community, and this is a good sign again that transformers are not just lab animals. They're out there, and people are using them. And so that materializes also on the Hugging Face Hub, which is our main website, huggingface.co. People call it the GitHub of machine learning. I guess the analogy works up to a certain point. This is where I guess pretty much everybody goes to find models and data sets and also share them, right? It goes both ways. So as of today, I think we have 78,000 models. So this slide is never up to date. I quit updating it. 78,000 models, 11,000 data sets, and day in, day out, we have about 100K active users, and way more than 1 million downloads these days. These days, I need to update that one, much bigger. So it's growing. It's a lot of people using us every single day. Here's a quick example. If you've never seen Hugging Face in action, this is really the simplest way you can use our models. You build this pipeline object from the Transformers library, defining only the task type. I'm using zero-shot classification here, which I really like because of the flexibility in labeling. And in this example, I use a Facebook, or I should say Meta model for classification. Okay, I just pass it a very weird sentence. This is actually from Wikipedia. And I just want to know if this thing is about science or finance or business or stock market or research, okay? And I just call it, okay? And immediately I get scores for each of those user-provided labels, okay? And that's it, no training, no machine learning, just, let's say 2-3 lines of Python. Your junior developer can do this in minutes, okay? And you can use all 78,000 models this way. Just like that, okay? And if a new state-of-the-art model shows up, just replace the model name in the pipeline, and that's it, you're done, okay? So as I say often, my job is to, and I guess Hugging Face mission is to make machine learning boring, okay? We want to make machine learning accessible to everybody, and this is one way of doing it. So Hugging Face at a glance, the family picture today is something like this. On the right-hand side, we have our data sets and models, okay, which you can grab using our open source libraries. And then, of course, you could work with them just like I showed you before, but in some cases, you want to train them a little bit. You want to fine-tune them on your own data. And you can do this in different ways. We have an AutoML service called AutoTrain, which supports NLP, computer vision, and tabular data. It's absolutely no code, right? There's not even an API for it. So it's completely no code. So in just a few clicks, you can train, fine-tune the top models from the hub on your own data. I'll show you a quick example. If you want to write code, then obviously you can use the Transformers library. I'll show you a quick example. And we have, I would say, lower-level libraries like Accelerate for multi-GPU, multi-TPU training with full control. And we have a library called Optimum for hardware acceleration, both at training time and inference time. Okay? So once you have a model that you like, what you want to do is demo it, right? You want to show it to your users, your customers. And if you run this stuff in Jupyter Notebooks, it's not super exciting, right? Especially if they're non-technical folks. You know, I've done this so many times. They kind of follow what you're doing, but it's not what they want. What they want is to solve a business problem with machine learning. So you need to show them something that looks like a real-life application. And that's exactly what spaces are. And we'll look at a couple of spaces. Spaces are just simple web applications that you can build and host on Hugging Face with just a few lines of code using either Gradio or Streamlit. Okay? And spaces they're 1 year old, I think, yesterday, and they're amazingly popular. And finally, if you want to deploy for production, of course, you can deploy anywhere, grab the model, build a container, host it anywhere. But as of a week ago, we launched a new service called Inference Endpoints that lets you deploy models from the hub in your cloud account on AWS or on Azure with auto-scaling and security. And I'll do a quick demo of that. And the last two options, obviously, we have partnerships with Amazon and, or I should say AWS and Azure. So you can train and host Hugging Face models on SageMaker, and you can deploy them on Azure as well. Okay. All right, so that's it for slides. Now I think we want to look at some code and demos, so let me switch to that. Go full screen. Is that large enough? Yes? Can you see okay in the back? Yeah? Yell at me if it's too small, okay? All right, so almost 78,000 models, and for all kinds of tasks, as we've seen, computer vision, NLP, audio, multimodal, tabular, reinforcement learning, new stuff coming up every day. And you could just go and look at any of those models, right? Get all kinds of information on the model. You can test the models on the page. But like I said, if you want to solve business problems with machine learning, which is what I'm all about, right? I want to show those models in action. And so this is really what spaces are all about. So starting from the simplest way to showcase those models, right? Here's an example of a space. So this is based on Layout LM, okay, a V3, so the latest version. And this is actually a space that showcases how to extract information from, invoices and this is a burger invoice, White Castle, okay? Good burgers, actually. So let's say you want to process that stuff, who loves to fill expense reports? I seem to be spending half my life doing this. This and the other half is booking airplane tickets. So I don't have much of a life. So we could just say, all right, please show me how that works. So I could just grab one of the examples, send them to the model, and this space will just process the image. And these are a little bit slow because they're running on CPU. And this is the output, right? And we can see, all the items and the prices have been detected and tagged, or I should say, classified, right? That's it. This is a pre-trained model. I didn't train this. I just grabbed this model from the here it is, from the Microsoft page, right? Microsoft published this model, and I'm just using it as is. And not even that, because I'm actually using a space that one of my colleagues has built to showcase the model. Okay? So imagine showing this stuff to your users instead of showing that same process in a Jupyter notebook. Completely different impact. And now, of course, you want to know how much code this is. And this is 97 lines of Python, but really there's, if you look at the code, like half the code is really the UI and drawing the boxes, the bounding boxes around the items, okay? Write this code. This is actually, I think this is Gradio, this one, yeah. This is Gradio. Push it to a Git repo that you created on the hub, wait for a minute for the container to pop up, and you're done, okay? This is the simplest thing ever. Let's do maybe another one. So why don't we do this one? Yeah, so this one is Donut, right? So Donut is a pretty cool model as well. So in this example, I've got this text document. So this is actually a conference program. I should have tried it on the on this conferences program. And I can ask questions on the document. So let's say I want to know who Whaler is. So I'm just going to say, well, who is Whaler? Okay, and submit. So typically people have been doing OCR, forever, and they scan the documents, and then they do some image processing on that, and then they do whatever they do on the document. Here we just pass the image itself to the model. Oh, that didn't work. Okay. Let's try that again. Yeah, Waller is Lee Waller. So it's a correct answer, but I'm looking for the job title. So here the document is actually passed to the model as is. So it's strictly working on the image and trying to find the answer. Hopefully it's going to find the answer now. Let's see. Yes. Okay, so Lee Whaler is the vice president of TRRF. Okay. Again, this is an off-the-shelf model, and I guess you could fine-tune it, but you could try it just like that, right? You could try it on your own documents and see how it works. And in a day, in a couple of days, you can come back with a POC and show it to your users and say, is this what you want? Okay? And maybe for extra accuracy, and you want to fine-tune this, and you can do both things in parallel, but you could have your Monday morning meeting with your VP marketing or whoever, and come and get the requirements, and you could come the next Monday with a demo that works, right? And there's probably no chance you can do this with traditional deep learning as we're doing it today. All right, so I could go on for hours just showing you spaces. Go and check them out. Now, let me quickly show you, this is actually an auto-train model, right? In case you need to train and fine-tune those models, one way is to use auto-train, right? And it's actually a simple way because you're not writing any code at all. And we need to be lazy, and I am super lazy. So here, I just grabbed the model. I just grabbed the data set, which is the Food 101 data set. Right? As the name implies, it has 101 classes of pictures showing different kinds of food. And I just launched an image classification job on AutoTrain, okay, with just 5 models. And this thing ran and it took me, a few clicks. And this thing ran for about 2 hours. Okay, and I can see my metrics. And the top model was actually this one, and it's automatically pushed on the hub, okay? And as a matter of fact, comparing to the top scores we have on the hub for this data set, this is actually the best so far. So how could I be state of the art? That's weird. And we can of course give it a try. Okay, so we can upload images just right there and run some predictions. Okay, right? So 21 minutes, and I still haven't written a line of code, which is great, because I want to go fast, right? So we'll get our predictions in a second. All models here are loaded on demand, so it takes a few seconds. But I could also, while it's predicting this, of course, we could also deploy the model, right, to a production endpoint and run some predictions in Python, for example, right? So here I see my inference widget prediction, right? And then, again, in just a few clicks, and I use the inference endpoint solution that we just launched last week, right? And let me show you how this works really quickly. You just enter the model name. Oh, here we go. Right? Select where you want to deploy. So right now we have AWS and Azure. What kind of security you want on the endpoint? So completely public, no authentication. Protected means accessible from the internet, but you need a token to authenticate. Private means it's deployed in a private subnet, and you can connect privately to it in your AWS account. And so that's what I did. I actually did a protected endpoint, right? So just a couple of clicks, and now I've got my URL. Okay, again, this is how I would predict. Endpoint URL, pass my token, load a picture, process it. Let's try that. Okay, that's it. Right? Anybody can write this Python code. Right? If I can, you can. Anyone can. Okay, deployment solved. So this is actually the workflow that we encourage developers and customers to follow. If you can avoid training, please avoid it. If you can stick with pre-trained models, you will go 100 times faster than you're going today. And again, it's all about getting to production quicker and creating business value quicker. If you need to fine-tune, why don't you try auto-train? Because it is saving you from writing code, right? And you can launch, 100 auto-train jobs in parallel on different data sets, different models, see how things go, right? And do useful work, high-value work in the process. Training is not high-value work, okay? And then you can deploy your model quickly and measure it and evaluate it and test it, right? So sometimes, yes, you do need to train and fine-tune, okay? But it's kind of last resort. I mean, I'm not excited about training at all. It's pretty boring to me. I'm excited about putting models in production that solve real-life problems. So if you want to go and train, then by all means you can. And this is just a very quick example of using the Transformers library if you've never seen it. So importing some objects. Here I'm going to fine-tune a distilled BERT model on an Amazon review data set, right? I'm training on a GPU instance here. And I can use FP16 training because this is so much faster, and all it takes is setting that parameter here. So loading my data set from the Hugging Face Hub in one line of code, okay? And this is what it looks like. The review and the star rating, the Amazon star rating. Define a metrics function for metrics, of course. Load the model from the hub and its tokenizer, one line of code, well, 2 lines actually. Tokenize the data set, 2 lines. And then put all my training arguments together, the learning rate, the batch size, the number of epochs, the FP16 setting, etc. Okay? And then the trainer object, the model, the parameters, the data sets, the compute, the metrics function, and then called train, okay? And it trains for 9 minutes on this GPU, and that's it, okay? And this code is very generic, as you can see. The trainer API, you can reuse again and again and again and again. It's not task-specific. I guess the metrics function would be a little bit specific. But, you could just copy-paste that code again and again and again and adapt it for different training jobs, right? Of course, if you love writing PyTorch training loops, you can do that too, right? You can do that too. You can load the models or TensorFlow training loops. You can load the models as PyTorch or TensorFlow models and write your training loops and customize. But the trainer API, again, will save you a ton of time. And then, we can use the pipeline again, just like we've done in that first example. Predict some shoe reviews, right? Or if we want to take it down one level, we can actually not use the pipeline and define our inputs, tokenize them in case we need to do some pre-processing here. Actually forward the data through the model and apply softmax to see probabilities, etc., etc., etc. But again, last resort, okay? We're trying to save you from the plumbing and all the nitty-gritty details, because again, what we're looking for is going as fast as we can from business question to POC to prod, okay? And anything that stands in the way, we're trying to eliminate or shrink. Now, obviously, this is a small training job, and some of our customers are training really, really big things with transformers. So that's why we spend a lot of time on hardware acceleration, as I mentioned before. We have an open source project called Optimum. You'll find it on GitHub. We actually have different versions for Habana and GraphCore and Intel, etc. And I'm just going to show you how easy it is to adapt the vanilla transformers code for Habana, the Habana Gaudi accelerator. Okay, and Habana Gaudi is actually an Intel company now. So literally, the only thing you need to do is this, right? I'm not making this up. You need to replace the trainer object with Gaudi trainer, and the training arguments with Gaudi training arguments, okay? And the code that you saw is exactly the same. And we just replace this and this. We run this on an Habana Gaudi instance on AWS, okay? It's the DL1 instance family if you want to check them out. And that's it. And now you're accelerating things massively, okay? And I'm not here to discuss benchmarks. I have some more content where I do. And I make a lot of friends on LinkedIn, as you can imagine, and elsewhere. But I'll go on record and say this is much better than every GPU I've tried. Okay, so shoot me, right? If you want to know more, I seem to be obsessed with hardware acceleration these days. So in the last week, I've done a video on Optimum Habana, Optimum GraphCore, and this new chip from AWS that came out a few days ago called Trainium, right? And full disclosure, I used to work for AWS. So that's why I use AWS, because it's the only thing I know remotely, okay? So yeah, hardware acceleration is really important. I'm focusing on training here. We also have inference acceleration solutions with ONNX, OpenVINO, and all that stuff is part of the Optimum library. So go and check it out. You'll be surprised how fast you can make your models, train and predict. Okay, and just a few lines of code is really what it takes. All right, and again, this could go on for hours. But I think the takeaway here is, well, if you've never tried Hugging Face, of course, I believe you should. But to me, the most important takeaway is this. And I've been saying it for a lot of years now, and I'll keep saying it. ML is complicated because we love to make it complicated. Okay? And that's a problem because we need every developer, every software engineer to understand the basics of ML, and particularly how to add state-of-the-art models to their app. Okay? I feel sorry for folks who are still using, I'm not going to name models because I don't need more friends right now. But old CNNs, old LSTMs from almost 10 years ago, and they think it's clever. Come on. You can get 10% or 12% or 15% more accuracy with the state-of-the-art models out of the box, okay? So we need everybody to do this, and that means it can't be more complex than just a few lines, right? So make sure you're focusing on the right things, okay? And the right things are business problems, okay? If you hear your boss saying, let's do machine learning because I want to know what the technology can do, okay, just say no, fight back, okay? If you don't have a business goal, you don't know what you're doing, okay? Unfortunately, this is still happening a lot. What's the KPI you're trying to improve? Click-through rate, conversion rate, spending less time in Zagreb traffic, which I seem to understand is an issue, et cetera, okay? Business metrics, not technical metrics, not loss values, not confusion matrices, no, that doesn't work for me. Save time. Start with pre-trained models, start with transfer learning, okay? Don't go and write your own TensorFlow PyTorch model from scratch because it will look cool on your resume. What will look cool on your resume is business impact with machine learning, okay? Don't reinvent tools, don't reinvent platforms, don't reinvent infrastructure, okay? I understand some folks need to have on-prem infrastructure because they have very strict compliance issues. For the 99.9% that doesn't have that problem, okay, you have everything you need on the cloud and elsewhere, okay? Focus on solving problems. Don't build a new machine learning platform because it will look cool on your resume. I already told you what would look cool on your resume. And finally, especially if you work in a bigger company, please collaborate, okay? Please exchange models, data sets. You wouldn't believe how many versions of BERT or vision transformers exist in your typical multinational. It's insane. Because the right hand doesn't know what the left hand is doing, right? And they don't have 2 hands, they have 100 hands. So it's crazy. So collaborate, use the tools that let you share knowledge and artifacts. Okay. All right, well, if you want to get started, these are all the good links. If your company needs help, we love open source, but we love to make money and generate revenue for the company, so we can help with that as well. That's not my story today, but feel free to get in touch. We can help across the spectrum from modeling to production. And if you want to stay in touch, you can find me on Twitter, YouTube, Medium, everywhere. I'm generally pretty easy to find. And yeah, please come and have a chat. I'll stay for a few more hours before I need to fly back. Okay. Well, that's really it. I hope this was useful. If you have questions, I'd love to answer them. And I want to thank you again for inviting me. It's really a pleasure to be here today. Thank you very much.